So this problem is a little tricky. It says to throw a discus, the thrower holds it with a fully outstretched arm. Starting from rest, he begins to turn with a constant acceleration, releasing the discus after making one complete revolution. The diameter of the circle in which the discus moves is about 1.8 meters. If the thrower takes 0.9 seconds to complete one revolution starting from rest, what will the speed of the discus at release be? So I'm gonna illustrate the problem and maybe do it the long route because I don't really know how to do it if there's a shortcut or not. So basically what the problem says is that we have a person here and he has an outstretched arm and he is releasing a discus. But before he releases the discus, he had made one complete revolution with the outstretched arm like this and released the discus at this point. And we're trying to find out the velocity, the linear velocity with which he released the discus, so the discus moved in this direction. So to do this problem, we are given that the diameter of the circle in which the person was, which the person moved before releasing the discus, was 1.8 meters, and the time in which he took to make that circle was 0.9 seconds. So how to approach this problem is first, how I approach it is first find angular acceleration, and from angular acceleration find out our angular velocity at this point when he releases the discus, and then find linear velocity. So we find out first our angular acceleration from the formula. Our change in theta equals to our initial velocity change in time. Our initial velocity change in time plus half our angular acceleration times our change in time, the whole square. Now we know our change in theta is essentially one circle, so that's 2 pi, like 2 pi radians. So that's 2 pi. We know our initial velocity, he started from rest, so that's 0, plus half, this is the angular acceleration, this is what we're trying to find. And we know our change in time as 0.9 the whole square. So doing our algebra, we end up with 2 pi times 2 over 0.81. And that's our angular acceleration. Let's calculate that real quick. So 2 times 3.14 times 2 divided by 0.81. So our angular acceleration is 15.51, let's say, radians per second square. So this is our angular acceleration. Now we want to find out our final angular velocity at the point at which you release the discus. So our angular acceleration is nothing but our final angular velocity minus our initial angular velocity over time. So 15.51 equals to, this is 0 because we start from rest, so our final angular velocity over 0.9. So what does that give us? 15.51 times 0.9, what does that give us? Gives us a final angular velocity of 13.95. That's radians per second. Now from our final angular velocity, we can find out our final linear velocity, which is nothing but our angular velocity times the radius. And our radius is 0.9, which is half the diameter. Our diameter was given to us as 1.8, so our radius is half that, so 0.9 meters. So we end up with 13.95 radians per second times 0.9 meters. So we end up with a value of 12.56, approximately 13 meters per second. And that's our velocity, or our speed of the discus at release.